Hello everyone, in this video we will be learning about similar triangles. Before going for the formal definition of the similar triangles, we will just understand the concept in a simple manner, that if you take two triangles, we can say that they are similar to each other if they have the same size, if they have the same shape and may differ in size, So, by looking at these two pictures of the same triangle, actually these are the pictures of the same triangles, but the thing is here the size of this is bigger and the size of the second triangle is smaller. So, we can say that these two triangles are similar because the shape is same, but the size is different. So, the figures or the triangles which have the same shape but they have different sizes are called as similar triangles. So, is it possible that we always just look at them and tell that these are the similar triangles and these are not? No, for that we have some criterion. Before going for that, we will have a look at this picture which will help us understand the similarity concept more clearly. Look at the picture of these babies, cute little babies. As you can see, this is the picture of the cute little babies. Now, if I am making a copy of this, suppose, obviously it means it is exactly the same as this. Okay. These two pictures are looking the same, right? Now, I am reducing the size of this. See the way I am reducing the size. Whenever I am reducing the size, both length and breadth of this picture is reduced or increased. So, now look at this. Are the two pictures still looking the same? Yes, they are same. But what is the difference then? The sizes of these two pictures is different. Shape is same, but the sizes are different. So, we can say that these two pictures are similar. So, what we have observed is whenever the second picture is increased or decreased, it is increased or decreased in proportion, means if the size is increased, if the length is increased, breadth is also increased. So, what does it mean? We will just now look at this. So, the first basic definition what we have seen for the similarity of triangles is the two triangles will be of the same shape and they may differ in size. For that, we have two criterions in terms of measurements, that is corresponding angles. If two triangles are similar, then the corresponding angles will be equal. Corresponding angles will be equal. What does it mean? So, if one angle of first triangle, suppose angle A of first triangle is equals to angle P of second triangle, and angle B of first triangle is equals to angle Q of second triangle. Similarly, angle C is equals to angle R. This is the first criterion in order to make sure that two triangles are similar. The second criterion is ratio of corresponding sides should be same. Ratio of corresponding sides should be same. So, what do you mean by that? So, if you take the first triangle here, the first triangle is ABC, right, and the second triangle PQR. So, if AB by PQ is equals to BC by QR, that is in turn equal to AC by PR, then we can say that these two triangles are similar to each other if the ratio of the first side to the ratio of the side of the second triangle, BC by QR and AC by PR are all equal, the ratios are equal, then we can say that these two triangles are similar. So, what was the first condition? That the corresponding angles should be equal, and the second is ratio of the corresponding side should be equal. Now, let us go to this definition. Now, you will understand it more appropriately. Similar triangles are the triangles if two triangles are similar, if their corresponding angles are equal and their corresponding sides are in the same ratio or proportion. Okay. Similar triangles are the triangles that look the same but the sizes can be different. This is the basic definition of the similar triangles. The symbol that is used for denoting the similarity is this one. So, in this case we can say that triangle ABC is similar to triangle PQR. Now, in this you can observe that we already said that angle A is equals to angle P, angle B is equals to angle Q and angle C is equals to angle R, and we had AB by PQ is equals to BC by QR and AC by, that is equals to AC by PR. Coming to the next one. So, the next thing is basic proportionality theorem, or it is also called as Thales theorem. In short, it is called as BPT. What does it mean? So, if you have a triangle, let us first read the statement. If a line is drawn parallel to one side of a triangle intersecting the other two sides in distinct points, then the other two sides are divided in the same ratio. What does it mean? Just look at this. So, what is saying, we will just understand each word by word. If a line is drawn parallel to one side of a triangle, if you are talking about BC here in this triangle ABC, ABC is a triangle, right? So, in this triangle, if side BC, for this side BC, a line is drawn. Okay, D is drawn. How is it drawn? In this D is intersecting the other two sides. What are the other two sides of this triangle? AB and AC at two distinct points. Yes, two different points. This DE is intersecting AB and AC. Then the other two sides are divided in the same ratio. So, how do you write? So, if what it is said in this statement is, if DE is parallel to BC, then these two sides, that is AB and AC, will be divided in the same ratio, that is AD by DB will be equal to AD by DB will be equal to AE by EC. Now, you will understand the statement more properly. Just look at this statement and also this definition given. If a line is drawn parallel to one side of the triangle, which side of the triangle? BC. Which line is drawn? DE. Then this line which is drawn is intersecting the other two sides. What are the two sides? AB and AC in two distinct points. What are the points here? D and E. The other two sides are divided in the same ratio, means AD, if D is drawn parallel to BC, if DE is drawn parallel to BC, then AD by DB will be equal to AE by EC. This is said in the Thales theorem or basic proportionality theorem, also called as BPT. Let us prove this theorem. For this, we will draw a triangle ABC, okay, and this, what is given? D and E are the points of intersection of this line DE on AB and AC. So, what we have to show? What is given? In triangle ABC, DE is parallel to BC and DE intersects AB and AC at D and E. So, in our triangle ABC, DE is parallel to BC and DE intersects sides AB and AC at D and E respectively is the given information. Now, from this what we have to prove is AD by DB is equals to AE by EC. For this we will do some construction, that is we will join this B, as you can see here, this vertex B and E, we will join this BE and we will also join C and D. Okay, we join BE and CD. This is the construction we are doing. And one more thing we are doing, that is we are drawing DM, that is perpendicular to AC, and EN is perpendicular, EN we are drawing in such a manner that it is perpendicular to AB. So, coming to the proof, what we have, we will find the area of triangle ADE. So, let me remove this first, we will be able to understand it better. If I am removing this, look at this, I am talking about triangle ADE. In this triangle ADE, we need to find the area of triangle ADE. So, we know that area of triangle ADE is nothing but, area of any triangle is half into base into height. Half into base is, in triangle ADE, we can take AD as the base because EN is the perpendicular or height. So, AD into AD into height is EN. Now, let us consider the triangle BDE. From triangle BDE, we will find the area of triangle BDE. Look at this triangle BDE. So, before that, you need to understand this thing, that if you have a triangle and suppose this is the perpendicular from the vertex to the opposite side, then this is the height of this triangle. Suppose you have a triangle like this, okay. Now, if I want to draw the height from this vertex, how would I draw? It would look something like this. Is it inside the triangle or outside the triangle? It will come on the extended side of the base, that is, it will come outside the triangle. Here is the same case. So, in this triangle BDE, the altitude or the height is outside the triangle, that is EN is outside the triangle. So, from this you come to know that the height can be outside the triangle as well. So, from the triangle BDE, area of triangle BDE, how do we find? Half into base is, what is the extended side? Half into EN is on the extended side of B, that is half into BD will be our base and height will be EN, okay, half into BD into EN. Now, let us find the ratio of this side, these areas. That is, area of triangle ADE is divided by area of triangle BDE is equals to, what do we have the value of triangle ADE? Half into AD into EN, and area of triangle BDE is half into BD into EN. Because EN are the same, we can cancel, and half can also be cancelled, which is in turn equal to AD by BD. Now, within the same triangle, now let us place these sides which we have removed just now back. Look at this. We will join D and M. Now, let us remove this one. So, again we will be considering the triangles ADE and another triangle is CDE. So, the equation 1 what we got is area of triangle ADE by area of triangle BDE is equals to AD upon DB. Now, look at this triangle. Now, consider triangle ADE and CDE. Now, consider the triangle ADE and CDE. So, in triangle ADE, this AE is the base, and this time we will be considering DM as the perpendicular or height. So, DM is the height of the triangle ADE and AE is the base of it. So, area of the triangle ADE this time will be equal to half into base, that is AE, into DM is the height. Whereas, if we consider the triangle CDE, here the base is EC and the altitude that falls outside the triangle, that is DM, is the altitude or height of the triangle CDE and CE is the base. So, the area will be half into base, that is CE, into height, that is DM. Then we will find the ratio of this area of triangle ADE by area of triangle CDE, that which we have calculated just now we will be using. So, area of triangle ADE is half into A into DM, we will write that here, and then area of triangle CDE is we got half into CE into DM. DM and DM can be cancelled and half can be cancelled. That will give us AE upon CE. But as you can see here, placing this back, consider the triangles BDE, this one BDE, and the triangle CDE, these two triangles. These two triangles have the same base DE and are lying between the same parallels DE and BC. So, in grade 9 we have studied that if two triangles have the same base, in this case the same base is DE and lying between the same parallels, that is DE and BC, then the areas of these two triangles will be equal. The area of these two triangles will be equal, that is area of triangle BDE is equals to area of triangle CDE. The reason being, triangles with the same base and between the same parallels have same area. Now, coming to the conclusion part, let us just observe this. Instead of BDE, just now we have studied, we have observed that BDE area is equals to area of CDE. So, instead of BDE, can we write CDE? Yes, of course, because these two areas are both the same. So, in the first equation, instead of BDE, I am writing CDE. So, area of triangle ADE, compare this and this one, area of triangle ADE by area of triangle, instead of BD we are writing CDE is equals to the same thing, AD by DB. Whereas, area of triangle, just now we have calculated that area of triangle ADE by area of triangle CDE, we got it as AE by EC. Just observe this, ADE by CDE, area of ADE by CDE, LHS of both this is same. So, we can say that both RHS are equal, that is AD by DB is equals to AE by EC. This is the required thing that was to be proved. So, when DE is parallel to BC, we can say that AD by DB is equals to AE by EC. This is the basic proportionality theorem.